Hello everyone, today we are going to solve few questions relating to displacement reaction. You might have come across question like this in the first chapter of chemistry, chemical reaction. Question like this one, what happened when iron nail is kept in copper sulfate solution? And question like this one where they give you the reaction and you have to give the reason why zinc replaced copper and why does the reaction proceed in this way, and they will give reaction like this and they will ask you which one among them will proceed and which one among them will not, and some question like this one. So in order to solve these type of question, first thing first, we're gonna study again what is the definition of displacement reaction and try to understand displacement reaction. So what is displacement reaction? A chemical reaction in which more reactive element displaces less reactive element from its salt solution, that is known as displacement reaction. Let us have a look at the representation of this reaction, that is displacement reaction, with the circle here. As we can see here, we have two reactants in the reaction site. The first one is the blue one, and the other compound, let's say we have this compound is represented by the yellow circle and the violet circle. So the moment these two reactant undergo chemical reaction, you will see here that the yellow one will go with the blue one and the violet will be left alone, while in the reaction site the yellow was with the violet one, but in the product site the yellow one goes with the blue one. So what does it mean? It means that the blue one is more reactive than the violet one and it replaces the violet one easily. Okay, so how do we know which element is more reactive and which one is less reactive? So we can actually do that with the help of reactivity series. This reactivity series is the arrangement of elements, mainly metal, in decreasing order of their reactivities. Remember, sometimes they call reactivity series and sometimes they might also call activity series. As shown here, in the reactivity series, the elements are arranged in such a way that the most reactive element is kept at the top and the least reactive element is kept at the bottom. So as we can see here, the topmost element is potassium and at the bottom is gold, meaning that potassium is the most reactive element in the series and gold is the least reactive element in the series. With the help of the reactivity series, let us solve those questions before. So here the first question is what happened when iron nail is kept in copper sulfate solution. As we can see here in the reactivity series that iron is on top of copper, which means that iron is more reactive than copper. Therefore, iron will replace copper in the copper sulfate solution. When iron nail is kept in copper sulfate solution, the iron nail becomes brownish in color by deposition of copper on the iron nail, and the blue color solution of copper sulfate changes to dirty green color due to the formation of FeSO4. Here is the chemical reaction where in the reaction site we have iron, that is the nail, and the solution, that is copper sulfate solution, which is blue in color, and in the product site we have iron sulfate, FeSO4, which is dirty green in color, and the copper metal. In this next question we have the reaction zinc plus copper sulfate will give us zinc sulfate plus copper. In this chemical reaction, the question is why zinc replaced copper in copper sulfate solution. The answer to this is that if we look at the reactivity series, we will see that zinc is above copper, and this means that zinc is more reactive than copper. So since zinc is more reactive than copper, zinc will replace copper in copper sulfate solution and become zinc sulfate. As we can see here in this reaction, we have copper sulfate, which is blue in color. The moment it reacts with zinc, it will give us zinc sulfate, which is colorless solution, plus copper metal. This next question, we have two reactions, that is iron plus zinc sulfate, which give us iron sulfate plus zinc, And the next reaction is magnesium plus zinc sulfate, which give us magnesium sulfate plus zinc. The question here is which among these reaction will proceed and which one will not proceed. So here again, if we look at the first reaction, we have these two metals, that is iron and zinc. If we look at iron and zinc, iron is below zinc, meaning that iron cannot replace zinc. Why? Because zinc is more reactive and iron is less reactive. But if we look at the second one, magnesium and zinc sulfate, so if we look at these metals, magnesium and zinc, magnesium is above zinc, meaning that magnesium is more reactive than zinc. So therefore, magnesium will replace zinc to give us magnesium sulfate, whereas iron will not react with zinc sulfate to give us iron sulfate solution. So this next question, give one example in case of the following reactions. When a more active metal displaces a less active metal from its aqueous salt solution. To answer this question, we can actually use one of the reaction we already talked earlier, that is iron displaces the copper from its aqueous solution of copper sulfate, that is Fe plus CuSO4 will give us FeSO4 plus Cu. This last question says that give one example when an active metal displaces hydrogen from dilute sulfuric acid. All metals which are present above hydrogen in the reactivity series can displace hydrogen from dilute acids. This is because these elements are more reactive than hydrogen. Example include zinc, sodium, magnesium. All these elements are above hydrogen. In the reaction of zinc with dilute sulfuric acid, zinc will replace the hydrogen in H2SO4, that is sulfuric acid, to give us zinc sulfate with hydrogen gas. So you can see here that there are many questions which can come from displacement reaction, and you have also seen that we can easily solve them just by knowing the reactivity series, knowing which element is more reactive than the other, and knowing this will also help us to know which reaction will proceed and which will not proceed.